All right, welcome aboard the spacecraft. There's a few tips I want to cover first, and that is first and foremost, when you're on auto fuel, you're burning a pretty extensive amount of fuel, and when you're time accelerating, the thrusters don't kick in. So whenever you're doing a real-time mission, you should always go aux on, rate command, and pull the handle. This will cause the spacecraft to start drifting, but as you can see, the spacecraft can drift all ways around while never hitting gimbal lock, regardless of what the gyros here have to say. We've just crossed the 90-degree yaw mark, or the minus 90, and we're about to cross the plus 90. We crossed 90 pitch, crossed 90 roll. None of these are going to cause gimbal lock. The second bit of advice that I would like to offer is when you are like this and you're spinning out of control like this center box here is how fast you're moving. You never want to be maneuvering any faster than this, any faster than what the thing can show you. And to simply stabilize out, you can see this pink needle comes with our pitch. This yellow needle is tied to our yaw, and the white needle is tied to roll. And now we can hold a very stable attitude. Putting it to auto, RSCS that is, will also bring you to an incredibly stable attitude without having to touch anything. So we can spin up, go on auto, and the rate stabilization control system should automatically bring it in. To be warned, sometimes the roll gyro can act a little funny. So it's recommended when the roll gyro starts doing that, when the roll system starts vibrating and the thruster is going like crazy, to go back to rate command. But this is how you can bring in your attitude, and as well, you can also pull the roll handle. Stabilize and pitch and yaw, and then manually stabilize roll on your own. This is also an option to correct that glitch. So now we need to talk about what gyro free does, right? So right now we are not in our retro attitude. If we go to gyro free, we can cage the gyros and go back to gyro free. Look at this. Now we show we're in retro attitude, but we know by the scope here, the periscope, that we're not. So gyro free is actually used to figure out an orientation from when you hit gyro cage. So we can see we've got some roll, some pitch, and some yaw. My personal choice is I always like to fix pitch first, then yaw, and roll last, because they all sort of affect each other a little bit. But we can see when I come back to 0, 0, 0, as best I can, we are in the same attitude that we were when we caged the gyros like that. Switching it back to norm activates the horizon scanner. So now, aligning to the retro attitude. When your gyro is norm, which it almost always should be, these needles here tell you your attitude. All we need to do is pitch up to pitch 0. Again, not maneuvering any faster than maxed out, otherwise we go crazy. And then we bring this in as close to center as we can possibly get it. We can do that as well. Now we can take yaw in. So We need to yaw to the right. We need to increase by yawing to the right. And we can see that yaw has affected pitch a little bit because we're on the horizon scanner. So at the same time, we can pitch down to compensate for this. And now the yaw needle is at 0 and the pitch needle is at 0. We can again stabilize as best we can. Now we just need to get the roll needle. And now we are in retro attitude. Sometimes I find myself panicking and I don't quite have the patience to do this. Another method, a very, very quick and dirty method, is using the periscope. If you request your altitude, we can see we're at 91.8 nautical miles. We can set that altitude into the altitude system here, 91.8, which is essentially 92. We could see that's adjusted the box here. Now, a quick and dirty retro attitude, which is not actually how you use this system, but it's a method I've developed that works every time. Just for emergencies, as best you can, line up the edges of the Earth with the black border that you created by changing your altitude. And to measure your angle here, to measure if you're going actually retro, find a landmark and see if it follows this drift. You can set the drift by doing this, and you can calculate how far off your yaw is. And if your yaw is exactly at 0 and 180, 90 and 270, and the landmarks are moving straight across, you're in a retro attitude, like that. Now, how do we go about picking a spot for reentry? My preferred choice is always right off of Australia, because it takes about a quarter to half a globe to actually re-enter. So we will be re-entering pretty close to Hawaii if we come do our retro right above Australia. So let's time accelerate to that point. Right here. Now we can choose to go auto or we can stay manual. For the purposes of this demonstration, I'll stay manual. Retro delay we would want to be normal, even in this instance. This is only for get back to Earth as fast as possible. We want it to be normal almost always, because when we activate the retro sequence, if we're close enough to retro attitude, the retro attitude light will turn green. And a few moments later, the retros will be able to fire. Remember to set up your temperature accordingly for an emergency retro. And stand by for retro fire. Make sure to hold this attitude, and you can see this is just about aligned with the black box, all edges of the Earth. But it's also 0, 0, 0, as long as you keep gyros on norm, like this. If your retros don't fire when this light comes on, simply just manually activate them. Once your retrofire is complete, retrojet on, emergency retrojet on. Make sure that your drogue deploy circuit breaker is also on, and auto retrojet on. You may need to manually jettison the retro because you've manually activated the retro sequence, and this is not a problem. Simply click. Now, a good practice for this is to yaw 45 degrees to the right before jettisoning your retro. Otherwise, when you re-enter, it could come back and smack you. Now we're jettisoning it away from us, so when it does hit the atmosphere and it slows down slightly before we hit the atmosphere and slow down, it will fly past us instead of into us. And this is the procedure for Gemini and Apollo as well. For your reentry attitude, all you need to do is pitch up. Now, in real life, the spacecraft automatically stabilizes at 2 points. 1 point is either the sharp end forward, which is bad because it's not the direction of the heat shield, or blunt end forward. So you need to make sure that you touch the atmosphere, blunt end forward. And once you have that, in real life, the attitude will stabilize. If you're entering sideways, the little flap on Mercury will also ensure that you enter the correct way. So if you're entering sideways, in real life, the craft will push you to this orientation. As you come down, you're going to want to sort of pitch up gently. And right when you hit interface, you're going to want to begin a roll rate, right? So roll doesn't exactly matter here right now. It's only pitch and yaw that matters. The Mercury capsule, it does not have a lift vector like Apollo and Gemini. So roll needs to be done with a specific rate. Otherwise, you don't get even heating, right? So when we hit interface, we can see aerodynamics have stabilized us. The yaw and the pitch cannot really move much anymore. And now all we do is we take this needle and we bring it maximum to the left or to the right. Not any faster and not any slower. And now the rates will automatically stabilize on this position. And we can see with our targeting, it looks like, yep, we're going to come down right next to Hawaii or in between Hawaii and California, right in the prime recovery zone. And we can see with no attitude control, I'm not touching anything. The spacecraft has automatically stabilized in the reentry position. And now reentry will begin. And if we go outside, we can see it has indeed perfectly stabilized us right down the middle with just a little roll. From here, the rest should be as normal. So just to review, this square here are your rates. We can see we've got a roll rate, and we can see that the aerodynamic forces are keeping us stable by bouncing us up and down, left and right, to average out at around 0 yaw, 0 pitch. When you want to retro, 0 roll, 0 yaw, 0 pitch, and gyro normal. When you want to re-enter, then you flip the switch to re-entry if you're on auto, or you gently pitch up to about here or here. Anywhere between this first mark and the top here, and your aerodynamic forces will automatically stabilize you on 0.5 G. And at 0.05 G, begin a roll rate not less than or exceeding the deadband of this rate needle. And from there, you don't need to touch anything. We can see we're gradually pitching up as we're coming down in the atmosphere, and we're staying right down the center of the plasma stream. And this is a quick and dirty way of performing the reentry in Mercury without the autopilot systems. The rest of it's normal. You wait for the drogue, you pull the snorkel and the O2 on time, water sealer regulators. The rest, I'm sure that you've done before and can manage from there.